Where is Pluto and why is it not what we thought it was? For decades, humanity looked into the darkness beyond Neptune and saw almost nothing. A faint dot. A frozen shadow, a forgotten world at the edge of the solar system. We called it a planet. Then we called it a mistake. Then we downgraded it, reclassified it, and almost dismissed it entirely. Pluto became a symbol of insignificance, a cold, dead relic drifting in silence. But the truth was far more unsettling, because Pluto was not dead. It was not simple. It was not what we thought it was at all. And what we discovered changed everything. Before 2015, Pluto existed only as a blur in our telescopes. Even the most powerful instruments could not reveal its true nature. Scientists built models, made predictions, and filled the gaps with assumptions. They believed Pluto was geologically inactive, frozen solid, and too small to sustain complex processes. It was supposed to be a quiet world locked in eternal stillness. But science has a way of humbling certainty. On July 14, 2015, NASA spacecraft New Horizons completed a journey of more than 3 billion miles and gave humanity its first close look at Pluto. What it revealed was not just surprising. Pluto was alive, not alive in the biological sense, but alive in motion and chemistry and energy. A world that should have been frozen in time was instead evolving, shifting, and rewriting the rules of planetary science. The first images came in, and scientists around the world stared in disbelief. There on the surface of Pluto was a massive, heart-shaped region, beautiful, symmetrical, and impossible to ignore. This region, known as Sputnik Planitia, was not just a visual curiosity. It was a massive nitrogen glacier stretching over 1,000 kilometers, slowly moving and reshaping the surface. Let that sink in. On a world billions of kilometers from the sun, before this mission, no one expected Pluto to have active geology. Too small, too cold, too distant. And yet the data showed something extraordinary. The surface of Pluto was young. Not billions of years old like we expected, but relatively fresh in some regions, constantly renewed by internal processes. This meant only one thing. Something inside Pluto was still active, and that is where the story becomes unsettling. Because for a world that's small to remain geologically active, there must be a source of heat, a hidden engine, a mechanism that should not exist but does. Scientists began to consider a possibility that once seemed impossible. Beneath Pluto's frozen surface, there may be a subsurface ocean, a hidden layer of water insulated by ice slowly moving beneath the crust. Think about that. An ocean in the darkness at the edge of the solar system. This is not just surprising. It is terrifying in its implications. Because if Pluto can have an ocean, how many other worlds might also hide oceans beneath their surfaces? How many places once thought to be lifeless might actually be dynamic, evolving, and possibly even capable of supporting chemistry far more complex than we imagined? Pluto was not supposed to challenge us like this, but it did not stop there. The atmosphere of Pluto revealed another mystery. Scientists expected a thin, escaping atmosphere slowly leaking into space. Instead, they found something completely different. A complex, layered haze stretching high above the surface, glowing blue in the sunlight. This haze is not just decoration. It is chemistry in motion. Pluto's atmosphere is primarily nitrogen with traces of methane and other hydrocarbons. These molecules interact with sunlight, breaking apart and recombining into complex organic compounds. These compounds form the haze that surrounds the planet. And here is where it becomes even more fascinating. Recent observations have shown that this haze plays a critical role in Pluto's climate, absorbing sunlight and re-emitting it as heat, creating a system unlike anything else in the solar system. A new kind of climate. A new kind of world. Pluto was not just defying expectations, it was rewriting them. Even its surface told a story of contradiction. Towering mountains made of water ice rose kilometers high. Vast plains of frozen nitrogen flowed like glaciers. Organic molecules known as tholins coated parts of the surface, giving Pluto its reddish hue. Everything about this world was active, dynamic, and complex. But perhaps the most unsettling realization is this: we were completely wrong. For decades we believed we understood Pluto. We categorized it, labeled it, and placed it at the edge of our mental map of the solar system. But when we finally saw it up close, it turned out to be something entirely different. This is not just a story about Pluto. This is a story about the limits of human knowledge. Because if we could be so wrong about a world in our own solar system, what else are we misunderstanding? What other assumptions are waiting to be shattered? Pluto teaches us something profound. Distance does not mean simplicity. Isolation does not mean inactivity. And small does not mean insignificant. In fact, Pluto may be one of the most scientifically important worlds we have ever studied. Its complexity suggests that the outer solar system is far more dynamic than we imagined. The Kuiper belt, once thought to be a frozen graveyard of leftover debris, may actually be filled with active, evolving worlds. Worlds with geology, worlds with atmosphere, worlds with hidden oceans, possibly worlds with the conditions necessary for life. This is where the fear begins. Not fear in the sense of danger, but fear in the sense of realization. The realization that the universe is far more complex, far more alive, and far more unpredictable than we ever imagined. Pluto was supposed to be the end of the story. Instead, it became the beginning. spacecraft that revealed all of this New Horizons did not stop there. Pluto. It continued deeper into the Kuiper Belt, exploring even more distant objects, pushing the boundaries of what we know. And with every new discovery, one truth becomes clearer. We are not at the center of understanding. We are at the beginning. Pluto stands as a reminder that even the most distant, overlooked corners of the universe can hold secrets powerful enough to change everything we think we know. It reminds us that science is not about certainty. It is about discovery. It is about being wrong and then finding the courage to look again. And perhaps the most inspiring part of this story is not Pluto itself, but what it represents. A tiny world billions of kilometers away changed our understanding of the solar system. Not through force, not through dominance, but simply by existing, waiting patiently for us to finally see it clearly. And when we did, it revealed a truth that echoes far beyond space. That the universe is not what we think it is. It is far more mysterious, far more dynamic, far more alive. So when you look up at the night sky and think about Pluto, remember this. You are not looking at a frozen relic. You are looking at a world that challenged science, defied expectations, and reminded humanity of something we must never forget. That no matter how much we think we know, there is always more waiting in the darkness. And sometimes what we find is not just surprising, it is terrifying.